today is the last of our 5 theorems that help us prove triangles are congruent. Today, we will talk about hypotenuse leg. The most important thing to know with hypotenuse leg is it only exists in right triangles. Because what's the theorem I told y'all doesn't prove congruence?
Donkey theorem.
Donkey theorem. Angle side side does not prove congruence. But look at this. Angle side side. So hypotenuse leg only exists in right triangles. Okay, and it's when the hypotenuse, what is a hypotenuse? Hypotenuse is the longest leg of a right triangle, and it is always opposite the 90-degree angle. So the side that is opposite the 90-degree angle is our hypotenuse. So opposite the right angle is our hypotenuse, and then a leg is one of the other 2 sides. Where else have we heard of legs in our triangles? What other triangles had legs?
Is it isosceles?
Isosceles. Isosceles triangles had legs and bases. So in our triangle, we've got AB is a congruent leg to DE, or DE. I'm listening.
Yeah, my thoughts are going to either.
Good. BC is congruent to EF. And then those are the only 2 pieces. So how many pieces do we normally need to prove triangle congruence? 3. What's the 3rd piece here? What do y'all think? What do y'all think the 3rd piece is? It is the right angle. It's a right triangle. That's our 3rd piece. So we can write our congruence statement now. As long as our hypotenuse is BC is congruent to EF, that's our hypotenuses. And AB is congruent to DE. Those are our legs. As long as our hypotenuses are congruent and one of our legs are congruent, we can say triangle ABC is congruent to triangle DEF. Hypotenuse leg. Womp, womp, womp. All right. We ready to do some math? Okay. All right, then. Love the enthusiasm we're displaying today. Yeah. So it says LMP and MNP are right triangles. So what if I told you that you did not have this? What if we take that piece out and we're just looking at the diagram? Could we come to the same conclusion that those 2 are right triangles based only off the diagram? Yes, why? Nope. So how do we know that MPL and MNP are MLP and MNP are right triangles without the given piece that it told us? What is this guy telling us?
That side is 90 degrees.
Okay, so this side is 90 degrees. What's that mean about MLP?
That it's a right triangle.
That is a right triangle. Okay, so now keep going. What were you talking about? If this side is a 90-degree angle,
that's the only other way. That means that one has to be a right triangle.
this one has to be a right triangle. So guys, remember back to unit 2. If 2 lines are perpendicular, it really forms 4 right angles. So with this side being 90, the other side has to be 90. And then even if you're like, oh, coach, I forgot about perpendicular, if you think about supplementary lines, which I think is where you were going, if this guy's 90, the only thing left is for that to be 90 because there's 180 degrees in a straight line.
90 plus 35.
Sure. You're absolutely correct. And then ML is congruent to MN. So we know that was part of our given. All right, let's work on our proof. LMP and MNP are right triangles. How do we know that?
Given.
It's a given. ML is congruent to MN.
The law of the angle bisector.
Given. So angle bisectors have to involve angles. Those are sides, so we don't have angles. MP,
Reflexive.
Yeah.
why is it reflexive?
MP equals MP.
So why does that make it reflexive?
They're equal. They're congruent.
They're the same thing.
It is a shared side. You're not wrong, but just I want you to recognize the shared sides. But yes, anything will always equal itself. That's the reflective property of congruence. So because it's a shared side. PM would also be reflexive because it's just the same side.
If PM was congruent to MP, would that be reflective?
Yes, because it's still the same line.
Yeah.
Yeah. And then, so why are our triangles congruent? So let's look. So we got opposite the 90 is our what?
Side angle side.
It's our hypotenuse. And then the shared side was in the middle. So let's think about, you said side angle side. Could it be side angle side?
No.
How come?
I said angle.
The angle isn't in the middle.
The angle's not included. You said what? Angle, side angle? How could it not be, how could it be side angle, side angle?
Because that's not a.
We don't know one of the other angles, right? So what do we call this? Because this is technically an angle side side, but Donkey theorem doesn't prove congruence. We call it what, as long as we've got a right triangle?
Congruent.
Hypotenuse leg. Hypotenuse leg. I've got a congruent hypotenuse and a congruent leg, so we are Gucci. WVX and XYZ are right triangles. Let's mark that right triangle. Whoop, there it is. And then it says X is the midpoint of WY. So what does it mean to be the midpoint? What do you mean the middle? So what does it mean for X to be the midpoint of WY? What does that create?
A shared side or shared.
What does it create? Two congruent segments. So that means WX is congruent to YX because of the midpoint. And then what was another piece of given? WV is congruent to YZ. All right, we ready to rock and roll? Yeah. All right, WVX and XYZ are right triangles. Given. WV is congruent to YZ.
Given.
They also told us that piece.
The next one, definition of midpoint, it says midpoint
Well, how do we know that X was the midpoint?
in the middle.
Nope. They had to tell me. If they didn't tell me, I couldn't assume it. So because X is the midpoint. That's our given. Now, however, how did we know WX was congruent to YX? Because of the midpoint, so we go to definition of midpoint. So it's not the definition until we use it. Once we use it, that's when we know. All right, so we've got, do we have a hypotenuse leg? Did they give us congruent hypotenuses?
Yes.
Yes? Do we have one pair of congruent legs? Yes. So why are my triangles congruent?
HL.
Hypotenuse leg. Hypotenuse leg only works in what?
Right angle.
Right triangles. Triangles with a right angle. That's fine.
Mine is right.
Oh my. What?
It says, oh my.
Oh yes. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Oh my. It is. It looks fun. All right. So we kind of talked through this cheat sheet in other classes. Puzzle piece. So if we're trying to use side, side, side congruence, what three pieces do we need? If we're trying to use side, side, side congruence, what three pieces do we need? Three congruent sides. Great answer. And if we're trying to do side angle side, what three pieces do we need? Two congruent sides and one congruent angle, but what's important about that angle? It must be in the middle. It must be where my two congruent sides come together. Fantastic. Angle, side, angle. Two angles and a side. And then we've got angle, angle, side. What's important?
Would the INC
Included. Yep. So angle, angle, side, and angle, side, angle both have two angles and one congruent side relationship. But what's the differentiation there? What makes it different? In our angle, side, angle, the side must be included between our two angles. But in angle, angle, side, the side is not. And if you look at the name, how many A's is this S touching? Two. How many A's is this S touching? One. It tells you what it needs to look like. And then finally, hypotenuse leg, what's our three pieces?
right angle hypotenuse.
Got to be a right triangle. We've got to have congruent hypotenuses and a congruent leg, one leg. All right, let's do some. So we're going to go through these, and we've got to figure out which one of these five we can prove triangles are congruent. Yes, that's why we're practicing it. All right, what are two things, well, three things that we can always assume?
It's got a side, an angle, and
No, what are our three congruent relationships we can always assume? Reflexive, which is what?
equal to each other.
A shared side or a shared angle. We can always assume vertical angles are congruent, and if I see parallel lines, which three angle relationships do I need to think of? Alternate interior, corresponding, alternate exterior. So when we're doing these, look for one of those three, because that's probably where it's going to be hiding. All right, number one, what piece of information did they give us? Did they give us enough?
Yes.
Okay. We've got two angles, so there's two congruent angles,
Side,
and so which theorems are we probably going to use?
angle, side angle, and angle, angle,
So it's going to be angle, side angle, or angle, angle, side.
Did you give me angle, side angle?
How come? So we've got our two pairs of congruent angles. And then where is that side at? In the middle. It's a reflexive shared side. So the question becomes, is my congruent side touching one or both of the congruent angles? Both. So what's our proof there? Angle, side angle. Can't write in highlighter, dummy. Every day. All right, number 3. What have they given us? Let's go ahead and mark it up. So we got a single angle there. Our double angle out yonder. And then a congruent side. So they gave us all 3 pieces on this one. We don't have to draw our own conclusion. So 2 angles, 1 side. It has to be which 2?
Is it angle, angle, side?
It has to be angle, angle, side, or angle, side, angle. But the question is our congruent side touching one or both of our congruent angles? Just one, so it's angle, angle, side. Just one. Angle, angle, side. Number 5. What do we know?
We know that there's congruent side on each side and then another congruent angle.
So we've got congruent sides.
We have 2 congruent sides.
And then what did you say about the angle?
That they equal, so it's reflective.
All right, so we've got our vertical angles, which is congruent. Do we have enough to prove congruence? Yes, with what theorem? Triangle? That's not a theorem. Side angle side, okay, because we got 2 sides and 1 angle. But why can't we use side angle side here? The angle is not included. So do we have enough information? No. So these are not necessarily congruent. What's that? Not necessarily. Because if they would have given me this side, it would have been. It's just a matter of which side they give me. Number 7. What do we know is congruent?
It's got 2 right angles and it's got
Do we know that they're right angles?
Well, if it doesn't have the squares, it's not.
We can't assume it, correct. So we've got these sides out here. That's not a highlighter, dummy. What else do we have?
We also have the 2 little circles.
We got 2 hoops, angles, right? And then what else? Is there anything else we can assume?
Yeah.
What? The reflexive shared side going down the middle. Do we know that? Yeah. How do we know the base is congruent? The hoops. What hoops? No, not because of those. It just means that they would be similar, not necessarily congruent. Yeah. Do we have enough information? What 3 pieces do we got? 2 sides at an angle, so it has to be side angle side. Is this side angle side? Yes. Number 9. What do we know? Okay, we got congruent leg, congruent hypotenuses, and it's a right triangle. Why side, side, side? So what do we call that? Hypotenuse leg. Two sides in a right angle or a hypotenuse leg? Yep. The last one. What do we know?
It's got two,
Two angles. Okay. What else? Which one?
Reflective side.
The reflexive side. Do we have anything else? Nope.
side, angle, side.
Could it?
Yes.
So we need three pieces. Do we got three?
No.
So we don't know if it's congruent. Not necessarily congruent. So now, instead of, we kind of can figure out the context clue of which theorem is trying to use to prove it, we're going to do kind of what we did on the last page. We're going to see what we've proven and how we can prove our triangles are congruent. So it says first, L is the midpoint of KN, and in L is the midpoint of KN. What does that mean? L is the midpoint. What does the midpoint do? It shows it's in the middle of a segment. So if it's in the middle, it creates two congruent segments. And then it said L is also the midpoint of MP. Those two sides are all, those two segments are also congruent. All right, was there any other given we can use? Nope. So how did we know L was the midpoint? Because we can't, that's not something we can assume. It was part of our given. How did we determine KL is congruent to NL? We use the midpoint, so we're going definition of midpoint. Def of midpoint. What about ML and PL? How did we know that was congruent? The midpoint again. Definition of midpoint. Angle MLK is congruent to angle PLN. So angle MLK is congruent to angle PLN. Why is that true? What do we call those angles? Why are they congruent though? They are vertical angles. Yep. So they're vertical angles. Vertical angles are always congruent. It's one of our things we can assume. Okay. So let's see. What have we proven? Statement 2, did we prove sides or angles? Sides. Statement 3, sides or angles? Sides. Statement 4, sides or angles? Angles. So we've got two sides and an angle. So which theorem do we have to use? Side angle side. But does side angle side apply here? Is our congruent angle included between our congruent sides? Yes. So why are our triangles congruent? Because of side angle side. B bisects ABC. So what does it mean for this line to bisect that angle? What does a bisector do? What does it mean to bisect something? Cut in half. So it cuts into two congruent angles. You are, my man. So that's our first thing. So that's BD bisects ABC. And then angle BAD is congruent to angle BCD. Facts. Straight facts. So BAD is congruent to BCD. All right. So how did we know BD bisected that?
Is there a given?
It's part of our given. Could we assume it?
No.
Negatory Ghost Rider. So what created the congruent relationship ABD is congruent to CBD? Well, God did create it, but in this instant, who was more direct? What created that blue congruent angle? The angle bisector. Definition of angle bisector.
And the next one's given.
The next one is given.
Another reflexive.
Why is it reflexive? Why is BD congruent to BD?
Because it's got two of the same and it's congruent equal.
But why do we see it as aggressive? Or why do we see it as reflexive?
Confusing a word and now I forgot it.
It's a shared side. Yep, shared sides are always congruent because it's the same line, just like you said it was. Okay, so let's look at our three parts we've proven. Okay, statement 2, is that an angle or side relationship? Statement 3, angle or side?
Angle.
Statement 4, angle or side? So it's got to be either angle side angle or angle angle side.
Angle side.
Okay, so you both said I like it. So why do you think it's angle side angle?
I said it's fine.
Angle side. Angle side angle.
Why do you think it's angle side angle?
Because you have the two lines,
Uh-huh.
A, and then you have the side, and you have the two lines.
Okay, so why do you think it's angle angle side? The side only touches one angle. So remember when we look at this, we look at it one triangle at a time. Does that congruent yellow side touch one or both angles? Just one. So it's angle angle side.